So as we move to more complicated computations where we have, larger molecules, we have more atoms, but we also have atoms that are further along in the periodic table, right, than just simply, carbon, hydrogen, and nitrogen and so forth, right, those second row elements, the computations can start becoming pretty long, right, to the point where they become a little bit unwieldy, especially for our purposes and what we have access to on the CCV. So one great benefit of using Orca over other computational software is that it has what's referred to as the resolution of identity approximation built into it, so you can call upon that to actually speed up a lot of the computations and add just like a minimal amount of error into it. So what we're looking at right here, right, is my WebMO job manager. And so I did the exercise with the 4-methoxy azobenzene compound, right? And I did, one set of computations where I went through the geometry optimization, the vibrational frequency calculation, and also the UV vis calculation, either just, plain, and then once with using the RIJCOSX, right? So that's just simply a derivative of the resolution of identity approximation. So what we can really see is a dramatic difference in computation time between these different parts, right? So if we're looking at the geometry optimization, we can see that the traditional one takes about 11 and a half minutes, whereas in the case, if we're using that approximation, it cuts it down to 4 minutes and 14 seconds, right? So we're already, being half the time. If we go to a frequency vibrational calculation, right, what we're looking at is something that, is over an hour, right? An hour and 11 minutes in this case right here is cut down to 7 minutes, right? That's a very dramatic change in computation time, right? So we can get more computations done in less time with only a minimal amount of error being introduced. Same thing with the UV vis, right? This is a pretty dramatic change where we're really close to an hour, right? We're 59 minutes just on its own. But if we use the RIJCOSX approximation, right, we're cutting it down to 2 minutes and 24 seconds. Now, you might be like, okay, well, how much error are we really introducing? So if we look at the UV vis, right, we can actually look at, how much do the different peaks, right? What are the energies and how much do those change, right? Because that's really what we're most interested in is, simulating a lot of the spectra so we can compare that to experimental data. So if we look at the UV vis here for the RIJCOSX, and so what I'm just going to do is actually just duplicate this real quick. So I'll pull up the UV vis for the RIJCOSX. I'll pull up the UV vis for the other one, and now we have both of these right here next to each other. Right, and so we can see the molecules, they essentially look the same right here, but now the interesting part, right, if we go to the UV vis, right, the excited states, peaks right here, right, so these are done exactly the same. We can see that, the first energy in the RIJCOSX is at 470.8 nanometers, right, and then it's 471.6 nanometers in the case of the standard one, right? There's a little bit of a difference in the intensity, but nothing dramatic. Right, and then the same trend, follows all the way down, right? The second excited state is 336.40, 336.70, right? So we're not really introducing a large amount of error, but we're speeding up the computation so much that for our purposes, right, we're only looking at this from the perspective of a synthetic chemist where we're trying to simulate spectra and kind of get an understanding, but we're not really going into like hardcore, deep p-chemist, theoretical chemist aspect of where we're trying to get these super accurate numerical numbers, right? We're really just trying to get an understanding of what it is that we're looking at. This is a really good tool to use in these cases, right? And so that's the big difference. And so when we, move forward with a lot of the bigger molecules, make sure that you click on the RIJCOSX, approximation, so that way that gets included and speeds things up.